window equalizes pressure during a tornado. The myth is based on a misapplication of Bernoulli's principle, which states that as the speed of a fluid increases, its pressure decreases. The theory is high-speed tornado winds create an extreme low-pressure zone outside the house. Because the air inside the house is higher than outside, people believe the internal air would push outward and blow all walls and windows out. First off, houses are not airtight. Buildings have enough natural vents to equalize pressure changes on their own. Secondly, violent, horizontal winds and debris strike a house long before the most intense pressure drop reaches it. Lastly, similar to an airplane wing, fast wind blowing over a roof creates upward lift. If a window is open, wind rushes in. The wind pushes upward on the roof. On the outside, faster winds are just above the roof, creating an area of lower pressure. On the roof below, winds are slower and therefore higher pressure. Wind blows from high to low, so it creates further lift. Here is an example of what we discussed in action during a tornado. Did you notice the roof lifting? Green skies equal tornadoes. Instead, it is purely an optical phenomenon caused by sunlight filtering through massive volumes of water and ice. It's often a recipe involving the time of day, cloud depth, and precipitation density. Most severe thunderstorms hit during peak afternoon heating just a few hours before sunset. Since the sun is low on the horizon, its light travels through a thicker layer of the atmosphere. This process scatters away shorter blue wavelengths via Rayleigh scattering, casting a warm yellow, orange, or reddish glow across the horizon. Severe thunderstorms feature incredibly tall cumulonimbus clouds that can exceed 50,000 feet. The massive concentration of raindrops and hailstones packed inside these deep clouds preferentially scatter shorter, blue wavelengths of light. Therefore, when warm sunset colors strike a storm's core, it's like mixing yellow and blue together, which make green. A green sky requires exceptionally deep cloud with immense water and ice content. These physical traits define severe thunderstorms, often supercells, rotating thunderstorms, which happen to be the breeding grounds for large hail and tornadoes and is why the myth persists. Overpasses are safe during a tornado. A prime example is during the Oklahoma 1999 tornado outbreak, where multiple people tried sheltering under an overpass and resulted in multiple fatalities. People were sucked out from under the shelter. Others were struck by high-speed debris. Vehicles piled up blocking escape routes.
That's partly because of television broadcasts of this tornado. It was filmed by a Kansas television crew who got too close for comfort. An overpass offered the only shelter.
Get up under the girders! Underneath the girders! Coming at us. Shove yourself right up underneath. And hang on to them.
That footage is where the myth originated, but there are 3 things to note. 1. The tornado was weak at that moment. 2. The overpass had an unusually deep crawl space. 3. The tornado did not pass directly over them. A totally different outcome than the 1999 Bridge Creek, Oklahoma tornado. The people were very lucky from the Kansas Turnpike tornado on April 26, 1991. A misconception is winds go up and wind is only inside the funnel. However, winds have a horizontal component, more so closer to the ground. Winds actually accelerate underneath the overpass, creating more of a danger. 5 words: never, shelter, under, an overpass. Tornadoes don't hit big cities.
April 27th, 2011. A monster tornado is plowing through downtown Tuscaloosa, a city of 93,000 people.
Those are just 3 examples of many times a tornado struck a city. Furthermore, urban cores make up about 3% of U.S. land area, so the probability of a direct hit is low. Make sure to like, subscribe, and comment down below for more videos like this.